So in 3/4, we're going to be solving quadratic equations using the factoring method. Okay, and because we are solving, we are going to be finding values for x or for our given variable. Okay, so today this is going to be our focus. We're solving by factoring. So in order to solve by factoring, we use this special property. It's called the zero product property. Okay, so zero product. Product means you multiply, right? So this is what it's based on. If you multiply two numbers together and it's equal to 0, you know that one of those has to be equal to 0. Okay, so you can only solve a quadratic equation when it is equal to 0. If it's not, you move everything over so that it is. Okay, and the zero product property tells us that if you multiply two factors, we'll call them A and B. If you multiply A times B, and that is equal to 0, then either A equals 0 or B equals 0. If two values multiply to make 0, you know that one of them has to be 0. Okay, so we can write this in our own words, just saying if the product is 0, if the product equals 0, one of the factors is 0. Okay, that's what that means. Okay, if the product is 0, one of the factors is 0. Okay, now notice that the directions say that we are going to be solving by factoring. So when you do something like this on an assessment, part of the points for that are going to be that you can factor completely. Okay, and then you can also check your solution by plugging that back in. So when it says to factor, you have to factor it all the way down. So I'm just going to put this reminder to factor completely. That means take out a GCF. If you have a pattern, you're going to factor down the pattern. All right, and then we are going to start with an equation. So up until this point, we didn't have equations, we had expressions. So now that we have an equation, we're going to be solving for x. So for part A, we have 61 is equal to x squared minus 3. Now, if this just said to solve, okay, this just said to solve, we'd add over 3, we take the square root, plus or minus. But it says by factoring, so our steps are going to be a little bit different. So the first thing we have to do is set the equation equal to 0. And to do that, we move all terms to one side. Again, we're doing this because it says we have to solve by factoring, so that's what we're going to do. So I recommend subtracting 61 to get 0 on the left. That way your x squared is positive. Okay, and then once you do that, now you factor. Okay, and this is our difference of two squares that hopefully we recognize because we practiced that in our warm-up today. So it should be x plus 8, x minus 8. Okay, and then the last step, we are going to be showing the zero product property. So for some of us that work work very fast in our heads. We're going to have to slow it down a little bit, and we're going to have to make sure we put in that last step, okay, where we are using this product property. Okay, so we're going to use the zero product property to solve. All that means is we are going to set each of those equal to 0. Okay, so in the zero product property, you're just going to show that x plus 8 equals 0 or x minus 8 equals 0. We know because they're multiplied together, one of them has to be 0. Okay, you don't need to show me the subtraction. As long as you have this step where you set each one equal to 0, that's fine. And then we would add this one over. Now this is going to be your final answer. So anytime you have to solve, you are going to be solving for x. Okay, let's try this again with part B. So first step is to set equal to 0. Well, the first step's already done. So now we're going to factor. Again, we have a binomial. Remember, your first step of factoring is always looking for what? Yep, look for the GCF. What do they have in common? Okay, so I want you to take out what they have in common here. So when you're taking out what they have in common, that can be numbers and variables, right? Okay, so Elliot, what did you take out for this one? Okay, so you can take out the 5. What else can you take out? The x. Okay, so I saw a lot of people take out the 5. Not everybody took out the x, so if you need to adjust that, please do so. And then when you take that out, you're dividing. 45 divided by 5 is 9. X squared divided by x is x. Negative 5x divided by 5x is negative 1 equal to 0. Okay, I can't break these down anymore. If this was 9x squared, I could, because it would be the difference of 2 squares. But if it's just 9x, can't FOIL it down. Okay, so then we're going to use the zero product property. So in order to get full credit, this is what you have to do. You have to show me that one of those is equal to 0. Okay, I know that many of you are going to know right away what this is. You just have to show the zero product property. Here we're dividing by 5. 0 divided by anything is going to be 0. Unless it is 0, then that's a mathematical conundrum that we'll talk about in pre-calculus next year. Okay, so your final answer is x equals 0 or 1/9. Okay, and the reason why we say the or is because it can be either one of those. Okay, those are your 2 solutions. Okay, what questions do we have so far? We're ready for the next one? Okay, let's try this. 16 equals 64x squared. Again, you're solving by factoring. You have to show the factorization here. Okay, if you haven't already, make sure you move everything to one side. It doesn't matter what side you move it to. I just like to keep that x squared positive so that it's easier for me to factor. And then we should notice 64 and 16 are both perfect squares. So this is going to be the difference of two squares. So to multiply to 64x squared, okay, you could try to get your 8x and your 8x. Okay, let's see if this works. Plus 4 minus 4. Okay, now once you get here, I want you to notice something. If you use your difference of two squares, because we are factoring, what do you have in each of these? You have a GCF, right? 8x and 4, what can I take out? 4. Okay, so if I take out the 4, I have 2x plus 1. And then I can do the same thing here, right? I can take out the 4. Okay, so this is going to give me 2x minus 1. And then your final answer, you're just going to multiply these two together. Okay, so you're going to have 16 times 2x plus 1 times 2x minus 1. Okay, now if you wanted to, some of you might also recognize that here you could take out the GCF. So if you do that, 16 is going to go into both. If you take out 16, you get 4x squared minus 1. And that's going to factor to the same thing. All right, and then when you are setting these equal to 0, the first factor, 16 equals 0, is there anything to solve for there? No. So you don't have to, you are not going to get any solution from that. So you just have to worry about the 2x plus 1 equals 0, which is going to give you negative 1/2. You subtract 1, divide by 2. The 2x minus 1 equals 0 is going to give you x is positive 1/2. So those are going to be your final answers. X equals 1/2 or negative 1/2. Okay, so when you are doing your factoring, make sure that you factor completely. Do you guys have questions on this one? I felt like most of you would naturally notice these are perfect squares and do this step first. Okay, but then when you do that, we just need to make sure we're checking for the GCF. So if we don't do it at the start, we can always check it here. We can pull it out later, okay, as well as at the end. All right, let's try part B. So for this, we have 25x squared minus 80x plus 64 equals 0. Okay, so this is a section that we're going to do with no calculator. Let's actually write that up here as a reminder. Okay, so if I do something that's 25 and 64, I'm not going to want to do that house method and multiply because those numbers are going to be really big. So instead, I'm going to think to myself, oh, 25 and 64 are both perfect squares. So when I start to factor, I'm going to try to split it up into 5x and 5x. I know if this is positive, the signs have to be the same. If this is negative, they're both going to be minus. and the square root of 64 is 8. So let's make sure that that FOILs back. 5 times 5x, yes. Negative 40 and negative 40, negative 80. Negative 8 times negative 8, positive 64. Great. So there's a couple different ways that you can do this. You can set each one equal to 0 and solve, or this is a skill that we're going to be working on as well. When you have 5x minus 8 squared, you're going to take the square root of both sides. And when you take the square root of both sides, we do the plus or minus, but 0, if you have plus or minus 0, 0 is not positive or negative. So you're just going to leave it. Okay, and then you would add 8, divide by 5. Okay, so x is going to be 8/5. Okay, so if these are the same factor, you will have one solution. Okay, so I want you to try this one. And if you get through that quickly, I'll give you F as well, okay? Okay, so once you move this over, because I want to keep the 16 positive, I'm going to move mine over to the left side this time. And you can decide where you want to move it, but if you are moving it over, will you just double check that you added it over, that you didn't just put the negative there? And then did we notice that 16 is a perfect square? Okay, so then we have 4x and 4x. That's how I would try it. Is 1 a perfect square? Absolutely. So let's see if this FOILs back. 4 times 4, 16x squared. 4 plus 4 is 8. Yep. 1 times 1 is 1. Great. So then I can just write this as 4x plus 1 squared equals 0. And then I can take the square root. Okay, and then if it's 0, again, remember, you don't have to worry about the plus or minus because it's just 0. Subtract over the 1, divide by 4, x would be negative 1/4. All right, so for f, we're going to add over the x. Okay, and if you want to do the house method with this one, it wouldn't be bad, right? You could do 6 times 12, the factors of 72, or you can guess and check. And you can decide what is going to work best for you. So you have two options, right? You can start with 3x and 2x, or you can start with 6x and x, or you can do the house method. Okay, if you're doing the guessing and checking, I do recommend just making a T-chart It's 1 and 12, 2 times 6, 3 times 4. Those are the only factors of 12. And then keep in mind, if you have a negative there, they have to be opposite. Okay, so go ahead and take some time to figure that out. The best thing you can do is practice it, not just watch me do it. And then if you finish that, feel free to start on example 3 and draw a picture. And then once you figure that out, I want you to read through the story problem. So when you're guessing and checking, the checking part is going to be really important because whatever you put here, whatever you put there, you have to multiply by 3, you have to multiply by 2. Okay, so if you put in like -4 and +3, this is -8x. 3 times 3 is 9x. 9 minus 8 is going to be +1. Yay. And then there's one more step now. So this is what we were doing yesterday. Today we just set each one equal to 0. 3x minus 4 equals 0. Or 2x plus 3 equals 0. And that's going to result in x equals 4/3. Or x equals -3/2. Okay, and then if you were using the house method, it was 72 was the number. So you should have split it up into 9x and -8x. Okay, and you can do whichever one you're the most comfortable with. All right, example 3. Let's read through this together. Highlighters ready. Okay, so a 12-foot by 9-foot fenced-in area has walking paths. So it's a 12-foot by 9-foot. I'm going to highlight that. Has walking paths along one of the sides, along one of the long sides and one of the short sides, with a uniform width of X. Flowers are planted in the remaining part of the enclosed area. The part covered by flowers is half of the entire enclosed area. So the covered by flowers is half of that area. What we have to find are what are the dimensions of the area covered by flowers. So when you have a story problem, if you aren't sure where to start, I would always just start with a picture. Okay, we can't just put down, I don't know. We have to make what we're trying visible. Okay, so let's start with a 12-foot by 9-foot fenced-in area. Well, I guess my dimensions are not so good. It's okay that it's not to scale. Okay, so then just label yours. So mine is 12 feet and then 9 feet. Okay, the more accurate your picture, the more it'll fit with your final answer. And then it says it has a walking path with a uniform width of X. We don't know what X is. So it says along one of the long sides and one of the short sides. Okay, so I'm just going to make this my sidewalk. This is my walking path. Okay, so a uniform width of X. So this has the width of X all the way around. Okay, the flowers are planted in the remaining part. Okay, so these are my flowers. They're so beautiful. Maybe a little tulip. Maybe a beautiful rose. Maybe this thing. Okay. All right. So now it says the part covered by flowers is half of the enclosed area. Okay. So let's figure out what that is. We know the area of the enclosed space is length times width. So 12 times 9, right? To do that without a calculator, just do 9 times 10, which is 90, and then 9 times 2, which is 18. Okay, so 90 plus 18, 108, and this is feet squared. Okay, and then if the part covered by flowers is half of that, the area with the flowers would be what? Yeah, great. Nice work. So we just take 1/2 of that 108, and we know that is 54 feet squared. Okay, so to figure out what the dimensions are, just keep in mind that this space here, right, this length is 12, but you have this little part X. So we can represent this as 12 minus X because of this space. And then here, this whole side was 9, but again, you can see there's that little spot X here. So we can represent this as 9 minus X. So now we know the area of the flowers is 9 minus X times 12 minus X, length times width, is going to equal 54. Okay, so if the whole length was 9, if we take out the walking path, it's 9 minus X. This whole side was 12. We take out the walking path, 12 minus X. So this is our length times our width of our floral area. Okay, so what we're going to do is we're going to FOIL. Okay, 9 times 12, we just did that. 108 minus 12x minus 9x plus x squared. Okay, feel free to rearrange it so it's in your standard form, but just like we did before, we're going to move everything to one side. So we have x squared minus 21x plus 108 equals 54. We're going to subtract 54 from both sides. So that it's equal to 0. Oh, sorry. Here, I'm going to write this first. X squared minus 21x plus 54 equals 0. Okay, and then we are going to factor that. Okay, so you can write out your chart for 54. Sorry, I really should have given us more room. So 1 in 54, 2 times 27, if I cut that in half. I know 3 goes in there because 5 plus 4 is 9. 3 times 18, and then you guys probably know that 6 times 9 is one of your facts. Okay, so what is going to add up to negative 21 and multiply to positive 54? They have to be the same sign. So it's 3 and 18. Okay, so your answers are either x equals 3 or x equals 18. You have to plug it in to find your dimensions. Should we finish this on the back so you guys have more room? So plug in to find your dimensions. Okay, so your dimensions are 9 minus x by 12 minus x. We're going to plug in our values for x there. And so I'm going to write those two here. So we have x equals 3 or x equals 18. The dimensions of your enclosed area were 9 minus x and 12 minus x. Okay? If you plug in 18, what is 9 minus 18? Negative 9. Is that a valid dimension? No, so that's not your answer. Okay, and then if you plug in 3, 9 minus 3 is 6. 12 minus 3 is 9. Okay, so your dimensions, you can either say 6 feet by 9 feet, or you can say 9 feet by 6 feet, does not matter. Okay, so if one of them produces a negative dimension, that is not going to be your final answer. Okay, your final answer is going to be a valid solution for the story problem. Okay, and then so for that one, you do have to make sure you're showing your work there.